Well, here is steering and suspension test 2. I hope you guys are enjoying this. I just wanted to run some more questions by you, and I go to quite a bit of trouble making these little illustrations, but like I say, if you've just got words on the screen and you don't have some kind of pictures, illustrations, or something, you've got a dull and boring presentation, and I try to avoid that if there's any way I can. Question 1, a vehicle wanders on the highway and requires constant steering correction. Which condition is most likely? Excessive positive caster, a worn upper ball joint, loose steering linkage, or 2 underinflated tires? Well, you're going to have loose steering linkage on that. If you're having to turn the wheel and if the wheels are able to make any of their own decisions independently of the steering wheel, then it's going to wander all over the road. You're going to have to you're going to fight it. And so that's the most likely cause of this. Now there's other, things that you might look at in your steering and suspension book that can cause wander. So do some research on that if you feel like you're going to run into trouble on that question on your ASC A4. Question 2, vehicle drifts to the left after a front end alignment. Which condition is most likely? All right, so you got having to constantly correct to the left here. I mean, for a leftward pull, you're having to turn it to the right. You got more positive camber, more left positive camber, more right positive caster, a worn idler arm assembly, or toe setting slightly negative. This one here is going to be more left positive camber. You can see it kind of makes a cone and wants to roll in that direction whenever it's tilted that way. This is an extreme illustration of that, but you see the point there. So it's going to pull that way. It'll also, even if you've got one that's all in the green on your machine, if you've got caster that's on the outside of the spec negative on that same wheel, and you got it on the outside of the spec positive, in spite of the fact that they're both in the green, if it's the most positive camber and the most negative caster, it's going to pull in that direction. And that's an easy trap to fall into. Question 3 is an easy one. We kind of covered it last time. Clicking noise is heard when turning sharply at low speeds. What's the most likely cause? A, power steering pump. B, worn outer CV joint. C, loose stabilizer bar link, or incorrect toot angle. Alright, clicking noise. There you go. Your outer CV joint does not plunge like the inner one does. The inner CV joint plunges for suspension geometry changes when you're going over bumps and stuff. The outer one enables you to turn. It's constant velocity because it's always pulling with the same amount. It doesn't go, like if you bend a drive shaft or a wiggler on your, like you got a impact wiggler impact wrench on a wiggle socket that's not made for impact. If you bend it too sharp, it gets hard and easy and hard and easy. That's why they call these constant velocity joints, which is like your impact wrench. CV. It's a CV joint on those, the ones that are made for impact wrenches. So it can produce the same amount of torque at an angle as it's producing straight without creating cyclic vibrations. All right, question 4. A vehicle has excessive body roll during cornering. Which component is most likely worn? Lower end ball joints, control arm bushing, stabilizer bars, and inside tie rod ends.
Shocks and struts. Worn dampers fail to resist the centrifugal force that causes leaning.
All right. A vehicle has excessive body roll during cornering. Which component is most likely worn? And that's going to be your stabilizer bar. I actually didn't make that answer very well. Stabilizer bar issue was not really, didn't line up with which component is most likely worn, which is silly. But it distributes the weight so that it keeps the vehicle keeps this body roll from happening. SUVs have got a sway bar on the back and on the front. Some pickups do. They do that because SUVs are more likely to roll over than the vehicles that sit lower to the ground. But even the vehicles that sit lower to the ground have got a front anti-sway bar. Police cars, like Crown Vicky police cars, used to have whenever they were using those for police cars, they have rear sway bars, and to make the thing a whole lot more stable on the road and less likely to turn over. Squeaking noise is heard during a sharp turn while driving over a bump. Which condition is most likely? Warped tie rod, dry steering stops, steering rack mount, or wrong caster angle? These are the dry steering stop issues. Whenever you're doing an oil change on one, even if you're not working on the front end, whenever you're doing your front end inspection, looking under there, if you're doing any upsell or whatever, and it needs to be done honestly, and don't sell anybody anything they don't need. But you can be a really nice guy for your customer, and amongst all the other stuff you're doing, you can give them a free swipe of grease right here from your grease can. Just smear some grease right there. Maybe put a little bit on here. This one here, you only got one steering stop on each side, but this one here, whenever you're turning it to the left, it's actually the one that's going to be your steering stop. If you're going over a bump and it squeaks up and down and it's dry, it's going to make a racket. You go to the other side, it's got a steering stop like this too. But like I say, you only got one steering stop on both sides. You don't need you don't need two steering stops on each wheel. You just need one on each side. But that's just a nice little thing you can do. Now this vehicle has this kind of tire wear on the front tires, which is alignment angle is most likely to cause tire wear like this. You notice we got sawtooth feather edges right here, and it's really smooth over here, and there's not quite so much wear over here. This is going to be a toe setting. Whenever the toe is set in and you're driving down the road, it's going to scrub the crud out of this and make feathered edges and all that, and it may make the inside look a little bit ragged. That's going to be a toe setting right there. Question 7, power steering assist is intermittent, especially during parking maneuvers. Which condition is the most likely? Loose power steering pump belt, dry strut mount bearing, bent lower control arm, incorrect caster angles. Now, strut mount bearings are interesting there. That's something that we have to deal with sometimes. Of course, you got your caster settings here, and you got a control arm. That's an A-frame, you want to call it. They look at there's no two different. There's a bunch of different kinds of control arms, but they all pretty much do the same job. And of course, you got your power steer in there.
At the accessory pulleys.
Right here, if you've got a slipping power steering pump belt, because it's got something on it, or the belt's wore out, or whatever reason it's slipping, or even if you've got a serious problem with your belt tensioner, or it's one of these belt tensioners that's not spring loaded, but you have to adjust it. If you got a loose power steering pump belt, you're going to have the jerky feeling like that, because it's going to come and go. You notice the power steering pump pulley is large in diameter because it needs a lot of belt surface. It doesn't need to spin that fast. It just needs to have a lot of power. Air conditioner compressors the same way. It doesn't need to spin that fast. It just needs to have a lot of power turning it with a lot of belt contact on the pulley. The water pump is not a positive displacement pump. It's just basically got that impeller spinning in there. So a lot of the times the water pump will be driven by the back side of the belt. They don't even have the the grooves on that. Your alternator needs to spin really fast, and it can actually, whenever you crank one and the belt's loose in the morning, you know how it'll squeal and holler because you've taken current out of the battery. The voltage regulator is telling the alternator it needs to up its game. The alternator takes more power to turn than you would think it would. If you ever noticed that an alternator, that, like for example, if you're working on one and you say, oh, I forgot to plug in the wires to the alternator here, to the little side connector on the alternator, engine's running, you reach over here and you plug them in, the engine loads up, see? So the alternator is going to take some energy to pull, and so that was one of the things. It's got a small pulley, it's got to spin fast. Anyway, this big pulley is for power rather than speed, and that's why the engineers have to do that. Vehicle exhibits a shimmy at 45 to 65 miles an hour. What's the most likely thing? A worn out tie rod, caster angle to negative, ring gear out of round, caster angle to positive. All right, so which is that going to be. Caster angle too negative will make that wheel, the wheel that's too negative, will act like a shopping cart. Older cars that didn't have power steering though, the caster angle would be set a lot more negative, so the car would be easier to steer without power steering. If the caster angle on a older non-power steering car was set too positive, it was hard to drive. Now when it's set more positive, it's more stable, and it wants to return to center, because when you got positive caster, when you turn the wheels, if you actually took a tape measure, you could measure this, put it between the level concrete and the bottom of your bumper, or make a little Sharpie mark on your bumper or whatever, and have somebody with the, and I don't like turning the wheels without the car moving, but just for the sake of this, you can put a tape measure there. When you are in the middle of that bumper, and you got a mark there, and you got your tape measure there, and the wheels are centered, you turn the wheels to the left, you're going to see the car raise up. You turn the wheel back to the center, it comes down to the same level. You turn them back to the right, it goes up. So it's basically always going to try to find that low center just naturally because of gravity when you have positive caster. Negative caster tends to not do that as much, and furthermore, like I say, negative caster is going to make the wheels act like shopping carts, and you know how they wiggle, 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 and shimmy. Question 9. Technician finds excessive play when rocking the tire at the 3 and 9 o'clock positions. Which component is most likely worn? Ball joint, tie rods, wheel bearings, A-frame bushings. Alright, now this is if you're going to 6 and 9, but you're not going to 12 and 6. Of course, anybody that's knowledgeable will do 6 and 9 and 12 and 6. In other words, they'll put their hands here and here on the tire, and there and there. And if it wiggles in both directions, it's liable to be a bearing, or it could be ball joint issues, but usually it's a bearing. And this one right here was a tie rod end that was worn out, and that's what was going on on the vehicle we were looking at. And so I kind of enjoyed doing that kind of thing and replacing tie rod ends and stuff. If you don't do it right, you know, you'll screw your alignment up pretty bad. But you can actually, if you're sharp enough, you can put a tie rod end on there and never even change the alignment, but you got to make sure you're careful how you do it, you know. Talked about that a little bit last time. Question number 10. We've been here 12 minutes. Vehicle's got hard steering condition at low speeds, but assist feels normal at highway speeds. Which condition is most likely? Incorrect toe setting, wrong steering fluid, an inoperative VAPS module, or 4 busted ball joints. That's going to be your variable assist power steering. And what they do, and they've been doing this for a long time on a lot of cars, the body control module usually handles it on newer cars. But it pays attention to the speed of the going down the highway, and whenever you're at highway speeds, it makes the steering a little harder, because that makes it feel, it gives you road feel, and it makes the car feel more stable. If you got real easy steering all the time, then it's going to feel squirrely out there on the road, feel like it's all over the road. But in parking lot maneuvers, they give you maximum assist. On the road, you have minimum assist. That's the way variable assist power steering works. There's also steering, you know, for some of the other vehicle dynamics, you got a steering wheel rotation sensor that tells how fast you're turning the wheel, and it's measuring brake pressure. Like if you're mash the brakes really hard, it needs to know that too, and it may have a fluid pressure switch for that reason. Particularly if you've got the dynamic suspension, you know, that stiffens the shocks whenever you're doing evasive maneuvers and all that kind of thing, which helps the sway bar. Anyway, so the caveat is, sometimes whenever the variable assist power steering malfunctions, you wind up with easy steering all the time in the parking lot and on the road. Makes the car feel squirrely on the road. On other vehicles, even within the same model, vehicle line, you may have, if the variable assist power steering goes dark, you may have hard steering in parking lots, but it feels normal on the road. And so, like for example, a Crown Victoria, if the variable assist power steering goes out on that, you'll have easy steering all the time. On a Taurus, if the variable assist power steering goes out, like if the gym module gets fried or something like that, you're going to wind up with hard steering in parking lots. That's where that will be noticed and all. But variable assist power steering has been out there for a long time. Okay, well, we've been here almost 15 minutes. Hope you guys enjoyed this, and let me know. Send me a howdy, and let me know if I've messed up on any of this or made any mistakes, and we'll talk to you next week.